Welcome to 10 Minute CS. This is 1371. Find the longest substring containing vowels in even count. So we will be given a string S. We have to find the longest substring in that string such that all the vowels appear in even count. Let's say for this problem, the longest substring will be this because all the vowels which are appearing in substring are E, I, O, which are appearing twice. All others are appearing 0th time, which is A and U. So the brute force approach that we can think of is we can find all the substrings which are there in this string and then can find the count of vowels in those substrings, and if they are appearing even number of times we can update our maximum length variable and finally return the maximum length of that substring. For this problem our time complexity will be O of n cube. We can improve the brute force solution by calculating the substring and calculating the vowel count in that same for loop. That will improve our complexity to O of n square. The pseudocode will look like this. We can loop over the string from 0th index to the last index. And then we can initialize the count of each vowels to 0. We can either use a frequency map or simple variables. And for each j from ith index to the nth index, we can update the vowel count if the character is vowel and check if all the vowels are even. If so, then we need to update the maximum length and then return the max length. Till now, we were storing our variables in frequency map. We can also store them in a bit mask instead. But if we'll store it in bit mask, we can use the property of XOR, that is, we can find if the given vowels are in even number of times just by doing XOR of it. So let's say we have 0, 1, 0, 1. So 1 is appearing even number of times. So and the XOR of these values will be 1. But if R1 is appearing odd number of times, that is the set bit is odd number of times, then our XOR will be 0. So with this simple XOR check, we can check if the bit values are even or OR. But how do we approach it? Also, we need to store if the given bit mask has appeared already in our string to calculate the length of that substring. So we need to store the values in a map. We can store the key as a bit mask and the index as the value as the index. So we can check for the bit in one operation and we will get the previously occurred index. Also, do we need to update this index each time we see that new bit? No, because let's say we have got that bit later in time. Let's say we first got it at 0th index and then we got it at 2nd index. We calculated the length of it. So should we update our index to this? No, because let's say we got it at index 3 also. So if we would have updated, we would have found the length of that substring as this, but this is not the longest because for that same bit mask we would have got the length as this, which is greater. So we just need to store the first occurrence of that bit mask and not need to update it. Let's look at the code. We will be having our map which will be storing the bit mask and the index we have seen for the first time. We will be adding 0, -1, that is our bit mask 0, 0, 0 is seen at the -1 index. This is for the case such as example 3 when we are having our output as the maximum length of the string itself. Because at the last when we'll see that we will check where we saw that bit mask at first, that will be at the -1th index. So we will calculate the maximum length as the length of string itself. We will be initializing our max length to 0 and bit mask to 0 at first. Then we will run a for loop over the length of a string and we will get the current character. We'll check if it's a vowel. For this we have created a private function which is simply checking if that character is a vowel or not. If yes, then we are returning true, else false. As we are already given that it only contains lower English letters, that's why we are checking it with respect to the lower English letters only. If it's a vowel, then we will update our bit mask with the XOR of the bit mask created with that character. For that, we will be subtracting our current character with A. So let's say we have E here, so this will give us 5 and we will be left shifting 1 5 times. And finally we will be XORing with the bit mask itself. Now whatever bit mask we have, if the map contains that key already, we will be updating our maximum length, because let's say we are here. So we have already seen the bit mask similar to E earlier also. So for this case we are seeing it again. That means that the number of E's that have occurred, or the number of vowels, if there were other than E there were A, I or O, whatever, that means it has occurred again, that same bit mask, then we will calculate the maximum length for it. And if not so, we will put it into the map, because we are seeing the bit mask for the first time. So why does it work? We'll see that. So let's say we are seeing the E for the first time, so we will be updating our map with the bit mask of E without updating our maximum length. That is true also, because E is occurring odd number of times. Now we see the E again. In this case, our bit mask would be already such as 0, 1, 0, 0, 0, and we have seen E again, and our bit mask, this one, will also be 0, 1, 0, 0, 0. Now if we take XOR of it, we will get again all zeros. That is similar to -1 case, that is all our zeros and our index is -1. That is, we have to calculate the length till here. So 2 minus -1, that is 3. So our maximum length will be 3. Now we see E here again. So we will be XORing it with the given bit mask and we will again get this. Now we have seen this bit mask, but it was here, that was at the index 0. So 3 minus 0, which is 3, that is the maximum length, and that is for this substring, and that is true, we have even number of vowels in this substring. And finally we will be returning our maximum length. For this approach we are using time complexity of O of n, as this function is just O of 1. And for space complexity we are using a map that will be O of n complexity. Thank you for watching.